So now let us start with the chemical properties of these particular elements. But before that, we have to look how does our main question that comes every time in the boards, that is, or in your unit test, it is that why does nitrogen only forms N2 and phosphorus form P4? The question comes like this: why does nitrogen exist as N2 and not N4? And the another way of asking this question is what? Why does phosphorus exist as P4 but it does not exist as P2? Right? So why is that? Let's see. The reason lies in the p-pi bonding. Going down the group, you people know what happens. The size of the p orbitals will increase. The size of 2p, the size of 2p is less than that of 3p, which is less than that of 4p. Going down the group, if my size of orbitals will increase, what will happen? The overlap between these orbitals will be going to decrease. That is why when you go down the group, tendency to form the multiple bonds decreases, right? And it so much decreases that phosphorus and arsenic and antimony and my bismuth never forms the multiple bonds. They only form one sigma bond. They can never form the pi bond. Only in case of nitrogen, it forms the p-pi bonding. That is what? My pi overlap, right? It can also form the pi bonds. While in case of if I give you the example of the next one, then why does nitrogen cannot show allotropy? Right? Nitrogen, why it cannot show why nitrogen cannot show the catenation? We have already discussed it, that because of the very small size of the nitrogen atom, nitrogen has high amount of electron repulsions, because of which what happens? The stability of nitrogen single bond is very less, and that is the reason also nitrogen forms multiple bond. Why? Because the electrons which are in the case of single bond, what will happen? In the case of single bond, what will happen? You have 1, 2, 3, 4. 1, 2, 3, 4. There are four. There are two lone pairs. There are four basically electron which can cause the repulsion. You make another nitrogen double bond. What will happen? Now how many will be there? 1, 2, 3. 1, 2, 3. Decreasing or not? The if the electron which is in the non-bonding pair, it is going into the bonding pair, what will happen? The stability is going to increase. Why? Because the electrons will be coming in between the two, right? So that is why if you further make nitrogen triple bond, only 2 electrons are there. That is why nitrogen prefer to form the pi bonds so that it can achieve stability. And you people know N2 is so inert that it does not even react at a very high temperature. You have to take it to almost 2000 Kelvin, which is around above 1700 degree or 1600 degree Celsius. At that point, it can react with your oxygen even. Right? So that is also the reason for the inertness. Now, why does phosphorus is not forming the pi bond? I have already told you, because of the size of 3p is very much, they cannot overlap sideways. Right? Then next comes is our why does phosphorus can form multiple bonds with oxygen then? Right? We can also ask this question. The reason lies in the p-pi d-pi bonding. Right? The d orbitals of the phosphorus, right? If you people know, the phosphorus has a electronic configuration of what? 1s2, 2s2, 2p6, 3s2, 3p3. That is the electronic configuration of phosphorus. Now, phosphorus can make up to the 5 bonds, right? What will happen? 1, 2, 3, 4 and 1, sorry, I forgot to write. And the fifth, it is NH2NP3, right? So what happens during the, from this electronic configuration, you can see phosphorus can make 3 bonds, but you people know PF5, PCl5 also exists. Why does it happen? Because the one electron is promoted to the 4d orbital, right? So that is why. Sorry, I have written 4d. It is promoted to 3d orbital, right? It is promoted to the 3d orbital, and when it happens, you have 5 unpaired electrons which can make 5 bonds. So the phosphorus tend to form pi bond using the p pi d pi overlap, the p orbitals of your oxygen and the d orbitals of your phosphorus, and that is why it can form a multiple bond, right? Nitrogen cannot form p pi d pi bond. Why? Because there is no d orbitals present in the nitrogen. What is the electronic configuration of nitrogen? It is 1s2, 2s2, 2p, 3. Even afterwards, it will be 3s0, 3p0, and then 3d0, right? So that is why, because there is no d orbitals present, no vacant d orbitals present in the nitrogen, it cannot form the p pi bonding. The p pi d pi bonding, right? Then anomalous behavior, that I have already explained you, that why does the nitrogen is so inert at the room temperature or even at a very elevated temperature? Because of the very high bond enthalpy. And I have explained you why this bond enthalpy is high, because nitrogen single bond is very weak, right? And the electronic repulsions are also very high. To overcome, it forms the multiple bond, right? And nitrogen exists as gas while the phosphorus exists as solid. This is also a very similar type of question, right? Because P4 exists. Why P4 exists? Because phosphorus cannot form the multiple bonds with it itself. So it preferred to use the catenation property, right? So that is why it exists as P4. And what is the atomic mass of phosphorus? It is 31. Right? In the case of P4, it will be what? 124. And what is the atomic mass of nitrogen? It is 14. 14 into 2, it is 28. Right? So where 28 gram and where 124 gram. So that is why P4, because the atomic mass is high, the van der Waals force of attraction will be higher, and that is why P4 exists as a solid while nitrogen exists as a gas.